page 11, I believe. If I'm wrong, I apologize. Definitely question 20. I'm starting to get a little dopey as far as what page we're on. Anyway, we are finally on some material that you could consider to be calculus. This is called the difference quotient, which is fancy talk for slope. Notice this is the change in y values, function values, or y values, and the change in x values would be, x plus h minus x. We've done this in regular pre-calc. Last year, you may remember doing this earlier in the year. While we're practicing putting functions into the difference quotient formula. So this is a big part of calculus. We'll have lots of time to do this also in class, but we'd like to see that you can do them for a few basic functions like linear, rational, and polynomials. So they're not too crazy in terms of the algebra, but so what we want to do is we're going to just take this function and put it into the difference quotient formula. Notice you all have, for each part, you have the f of x part already done. And then they want us to simplify it, and that's where the pre-calc knowledge comes into play. So what we're going to do is we're going to just find out what f of x plus h is. So if f of x is 2x plus 3, f of x plus h is 2 times x plus h plus 3. We'll just write it in difference quotient form. So f of x plus h minus f of x all over h is going to be 2 times x plus h plus 3 minus the quantity of 2x plus 3 all over h. And the good thing about difference quotient is when you do it right, everything should sort of cancel out, so it looks like a nice pretty end result. So 2x plus 2h plus 3 minus 2x minus 3 all over h. And if you look, notice the 3's drop out, the negative 2x's drop out, and you're left with 2h over h, which the result is just the 2. And shouldn't the slope, I said difference quotient is slope, shouldn't the slope of a line that has a slope of 2, shouldn't the difference quotient also be 2? So anyway, that's just a little check. For the next one, we're going to do f of x plus h again, but in this case, the x is in the bottom, so that's where we're going to put the x plus h plus 1. So now when we assemble our difference quotient, we're going to put the right parts in the right locations. So I'm going to replace that with 1 over x plus h plus 1 minus 1 over x plus 1 all over h. So this is the first, you have to get to this step to get the answer. Now we've got to combine these two fractions. So we've got to come up with common denominators. And this is where things get a bit crazy. So honors pre-calc kids should definitely be okay with this in terms of what I'm going to do here. The regular pre-calc kids, we may need to work a little bit after school to understand the steps. So just to set your expectations. The common denominator between both of these fractions, because I want to subtract these two fractions, this one and this one, the common denominator between both is going to be x plus h plus 1 times x plus 1. And then minus the other denominator will be the same thing. And then the numerator was a 1 before, but now I have to multiply it by what I added to the bottom, which was x plus 1. And in the second fraction, this one, I have to put x plus h plus 1 in the numerator. So now I've adjusted the numerators while finding common denominators. So now I'm just going to work on simplifying this. So I've got x plus 1 from this part minus x plus h plus 1 from this part all over the common denominator of x plus h plus 1, x plus 1 all over h. So now this is looking pretty crazy, I know. the top portion is things are gonna, I've got to subtract that, right? Things are going to simplify, trust me. So I have x plus 1 minus x minus h minus 1. That's just from working with this top part. I'm not going to touch the bottom part because that's like multiplying. You'll see in a second. I'm just going to leave that alone for a moment because I'm just going to focus on simplifying the top. And if you look at what simplifies in the top, the x's cancel, so they're going to be gone. The 1's cancel, and you're going to be left with just negative h over that ugly looking trinomial times a binomial all over h. Well, here's the good news. The h's cancel. So we end up getting negative 1 over x plus h plus 1 times x plus 1. And this would be your final simplified difference quotient. Believe me, I anticipate having many questions on this in class, but we all will be able to do this by the time we take our summer homework test. So just want to put that out there for you to look at it, but you'll be able to do that. The next one is just the regular squared function. This will actually be easier than the last one because it doesn't really require working with fractions. So f of x plus h for this one will be just x plus h squared. So now when we put this into the difference quotient formula, we have x, well, I'll just write out the difference quotient formula, f of x plus h minus f of x all over h. So I'm going to put the first part in. Now I'm going to actually do the math, and I'm going to take that and I'm going to FOIL it, or multiply the binomials. So we got x squared plus 2xh plus h squared minus x squared all over h. What you should see now is that the x squareds cancel. I have 2xh plus h squared all over h. And then I can factor out the h. You have to factor the h out to make sure you can cancel the h with the bottom. And your final result of your difference quotient simplification is 2x plus h. Now, there are some people out there that will take a different route with this. They're going to notice that this is the difference of squares. Now, notice that's a perfect square and that's a perfect square. Well, remember that whenever we had difference of squares, that equaled x plus a, x minus a, right? Just as a sample. Well, this one we can turn into x plus h plus x times x plus h minus x all over h. There's the plus and minus part. And what happens is you end up in the first term getting 2x plus h times, in the back part you get h, because the x's cancel. And then that results in you just having 2x plus h once these cancel. So notice we get the same answer. And so now we're moving on to, we're on the next page. So let me see, I've probably gone way over time. And we'll stop page 11 here, I believe. I think it's page 11. Anyway, we'll get working on page 12.